It's my pleasure to introduce the last group here, the salty eggs. They've been doing some work with frog work. I was going to tell them they need to see the song. They've worked with me for quite a while, and they got to hear some of my esoteric music, but I didn't get to introduce them to the last Saskatchewan Pirates. So they need to see the Salty Bob. They got the salty eggs. So we'll have to introduce them to that. So they're going to tell us about some of the work they were working with me.
All right. Hello, I'm Logan, Kirk.
I'm William McCormick.
And we've been working with Dr.Rayburn on the African claw frog and looking at malformations due to saltwater concentrations getting to freshwater. And this research is important because saltwater incursions into freshwater coastal regions can really affect the frog species and also lead to malformations in the tadpoles at a very young age. And this can come from different ways. It runs off from salting streets, especially with the snow that just came. It can also directly affect the frogs and get into the freshwater currents because when it runs off the road, that's going to be the first thing it does. And
during the experiment, we used tadpoles and eggs of the African clawed frog because the tadpoles of that species are clear and very easy to breed.
And I'm going to go ahead and start the iMovie or whatever. We use the iMovie rather than a presentation. But this is just some photos of us, and we're going to talk over it. That's okay with you.
Photos and videos.
And we also had two other group members that worked with us there in the back, Travis and Patrick. But this is some of the formulas we use to start the concentrations to use in our experiment. That's Dr. Rayburn, and it leads to our final volume that we're going to use. And this is some of the photos of us doing the 6-cysteine, and this right here is Fetax and controls. Basically, we're just going to use the Fetax to run the experiment.
We had two sets of controls, meaning there were 4 of them, and had varying concentrations from 2 parts per thousand to 3, and so on to 10.
And that's a photo of it right there. The different concentrations are going to affect the frogs differently. You'll have different mortality rates between these different parts per thousands. And this is just another photo of that. And we would do all this process, make all of our concentrations, and then we would run the experiments. We've ran 2 experiments so far, and neither one of them have been very successful. We hate to say that. The first one, the 5 PPT up, they died in the first 24 hours, so we weren't able to collect a lot of data through our experiment.
The 2 PPT controls and 4 PPT were all okay, but death occurred much faster than we had initially expected.
And also the second experiment, we were up here, I think it was last Tuesday, directly affected by the snow. And the transportation, of course, probably deeply affected this. And because we transport them by putting them into tubes, and that's probably not a good way. We take them back to the high school and use them in our lab, but we think the transporting directly affected the second experiment a whole lot. And this is just some more liquids or whatever we made, using the pipettes and things along the lines of that. Dr. Rayburn had the joy of teaching us how to use the pipettes. We had some trouble with that to begin with.
And while we're talking about the trials not going as we expected, we believe the first trial, we have reason to believe it went wrong because we might have put them in the cysteine solution too long when we were trying to de-jelly the eggs, and that might have somehow affected the results we got.
This is just some more of the, once again, the liquids. Coming up next will be us adding the salts to the concentrations, and it should be coming up here soon, I think. But one of our group members, he breeds frogs. So he conducted some of the experiments himself. So him and Dr. Rayburn just sit there and they talk about the different results they got. He'll run an experiment at JSU and Travis will run one at home. And then we'll just see how they differ.
All the trials were run over a period of 5 days, so We would start on Monday as day 0 and then end on day 4, which would be more often than not Friday.
As I said, is the trials not being very effective. Our data sheets we're not able to present them because they weren't that great of data because we felt like the experiments weren't ran. But this is a continuing process, so we hope to get better experiments in the future to really show how this really affects the frogs.
And these are images from when we were adding salt to the solutions to begin with, basically creating the solutions in the first place.
I believe that was the cystine process that we were using there, working to degelate the eggs so we could sort them. And this is where this comes into play. We'll just set the frogs. We'll put 20 in each container, and right here we would sort the frog eggs and really just see which ones were bad and which ones were good. What we're looking for is that we're looking for all the cell and the molecules so we can really tell the difference between the good and the bad.
When we found 20 good eggs, we would move them into a container and they would be used for the trials we would run later.
That's a picture of Patrick who's sorting frog eggs. I believe I have a video coming up of him doing so and then transporting it to a different container. Yeah, here's the video here.
A video of the transportation process of the eggs, moving them from the original container to the containers used for our test.
As you can see, they're sorted differently. Basically, under the microscope, you just push the bad eggs out and just use the good eggs in the experiment. Because if we really need to do this and make sure we're running really good tests on these frogs. And these are some of the pictures of the tadpoles right here. That's the beginning. They really look really small. They're very immature at this point. And this is us when we were looking at malformations in the tadpoles. Dr. Rayburn pulled that up for us, and we got a picture of it. A lot of the times you'll see it in the spine and in the head region of the swelling and other things along the lines of that. These are just some more pictures of tadpoles. We'd also run length measurements. We'd use a ruler, and Dr. Rayburn showed us how to do that, and we'd just make sure that the length, they're growing to the right size. And that is all we have, so.
We would like to say thank you to Dr. Rayburn and Dr. Klein, the people at JSU, for letting us do all this stuff there and letting us come over to prepare for these experiments, and for letting us come here today.
All right, any questions?
Yeah, so could you summarize your final result, what you got?
The final result, you mean in the trials we ran?
Yeah.
Okay. The 5 in the first one, the 5 PPT up. So the higher solutions were the ones that died in the first 24 hours, and the controls and the FETAC solutions and things along the lines of that, they were to last longer. And in the second one, the 5 PPT died last. They were actually the last to die. That experiment was a little bit more clear than the first one, but we're just looking for one experiment we can really, just get rid of all this transportation issues because of the snow and things along the lines of that. We can really clear that up.
So personally, what do you learn from this?
Personally, I learned that these salt concentrations are bad. The bigger concentrations are really going to affect the growing developments of these frogs, and it's something we need to look at.
What about you?
Something similar, basically that the more that the salt affects the contents or the liquid or anything that the frogs or tadpoles are living in, the more likely it will be to cause malformations or other oddities within the frog's systems, which will eventually cause problems for said frog in the long run of its life.
Why did you pick the concentration of salt that you used?
I think we used the concentration of salt. I'm really not sure on that, but that's kind of just what we came into, just use salt,
mean-
so.
Somebody tell you what to use, or you select what you want?
We just ran the salt test, like, we
mean-
just,
But to answer Dr. Blair's question, is somebody, for example, Dr. Rayburn tell you this is what you need to use, or you just choose basically you choose the numbers?
we just keep it in between the controls to the 10 parts per thousand. We stopped at 10 parts per thousand. We
Okay.
didn't go any higher than that. I didn't get what you were saying, but yes, sir. We stopped at 10 parts per thousand. We didn't go
So
any
Dr.
higher.
Rayburn told you that?
Yeah, yes, sir.
Okay, well, that's good.
Any more questions?
Is Travis here?
Yes, he's back
in the
there.
back.
He's right there.
You have a lab for breeding frogs at your house?
More like my room.
In your room? We must have the coolest parents on the block.
I love salamanders and amphibians and fish and all that stuff, and I'm like constantly raising stuff like that, and I really like it, so.
Sweet. That's great.